Hi students, in this video we are going to discuss about instruction cycle. Uh, Instruction cycle is also called instruction life cycle or instruction stages. Here are some instruction stages or instruction cycles. Before we are going to discuss about instruction cycle, what do you mean by instruction cycle? Instruction cycle covers the lifespan of instruction, how it is carried to the ALU, where it is created, from where it is carried, where it is stored, all the things. Okay. Before knowing about the instruction cycles, let's move towards some important parts like registers. These are some registers we have to discuss. First of all, what is register? Register is a small storage space. Our CPU need to work, and CPU needs some space to do work. Okay, while CPU is executing, maybe it needs some space to store the result, or it needs some space to store the instruction. Okay, the register provide this storage. Okay, actually the registers are inside the CPU. Okay, let's discuss about these registers. First, here is a program counter register. Program counter. First of all, there is a term counter. Counter means count. Program counter register holds the address of next instruction. Which will be executed or fetched. जो इंस्ट्रक्शन हम आगे जाके अभी जो करंट इंस्ट्रक्शन है उसके बाद हम जिस इंस्ट्रक्शन को एग्जीक्यूट करेंगे वो किस में रहेगा, प्रोग्राम काउंटर में उसका एड्रेस रहेगा, नॉट द इंस्ट्रक्शन. द एड्रेस ऑफ द इंस्ट्रक्शन विल बी स्टोर्ड in the program count which will be execute after the current instruction. Then हमारे पास आया memory address register. It only holds the memory address. The memory address may be of data, may be of instruction, it does not matter. It only holds the memory addresses. Then there is a memory buffer register. This register holds the memory data or memory instructions. Memory can store both data or instructions. Okay, memory buffer register can store both data and instruction. Memory can define what he is holding. It may be data or it may be instruction. Memory is a storage space. It only provides space for storage. The memory buffer register is also a storage space. It's also a register that provides some space for memory data or memory instructions. Then we have our next register, which is instruction register. As you are noticing, instruction, it holds only instruction. It holds only instruction. It can't hold the data. Okay, memory have both data and instruction, but the instruction register only hold the instruction, can't hold the data. Then here is MDR, memory data register. It only holds the data. It can't hold the instruction, or it can't hold the address. Memory buffer register can both hold data or instruction, but memory data register only hold data and instruction register only hold instruction. Okay, Then here is another temporary register. It's used for temporary storage during our CPU executing. Then here is a PC++, incrementing PC value. Okay, first of all, now you are executing a current instruction 1, then the next instruction is instruction 2, and let after the instruction 2 instruction 3 will be executed. We have instruction 1 is executing right now, and program counter value is instruction 2's address. Okay, here PC++ means when we are executing instruction 2, our PC++ will be done, or incrementing PC value. Incrementing PC value means we are loading the next instruction address, which means instruction 3's address. Okay, it's clear. Then move towards our control unit. Control unit plays a vital role because decoding the instructions will be done by our control unit. Decoding the instruction have many things like destination of operand, destination of the operation, or operand address, or operand itself, or opcode. Many things there may be in a instruction. The instruction will be decoded by our control unit. You have cleared about the registers. Now move towards our stages or instruction cycle. Okay, here we have discussed about 4 stages, which is instruction fetch, then instruction decode, then read the effective address from memory, then execute the instruction. It is also called IE, instruction execution, instruction fetch, then instruction decode. You also find some extra stages like instruction fetch, then instruction decode, then instruction execute, then write back. You also find these 4 stages in some books. Okay, these 3 stages are most important. Let's go for a discussion. Now we will be discussing about fetch cycle. What is fetch cycle? First of all, fetch means you are acquiring the instruction. Okay, and we have discussed about program counter. Okay, program counter have the addresses of the next instruction which will be executed. Okay, program counter have the address, and the memory address register can store the address. Okay, the address from program counter goes to memory address register, and memory address register is connected to the address bus. I have discussed about buses in some other videos like data bus, address bus, or control bus. Then through the address bus go to memory. Then the data from memory came to the memory buffer register through data bus. Through data bus. Okay, this is address bus, this is data bus. Then from memory buffer register to instruction register. Memory buffer register to instruction register through data bus. This is the instruction fetch. How the instruction is going from program counters to instruction register. This all about fetch cycle. And here also what happened after the instruction address goes to the memory address register, the PC value will be incremented. PC plus plus means the next instruction will be loaded. The next instruction will be loaded to the program counter. Let's again discuss about our phase cycle. First of all, address from program counter goes to memory address register, then memory address register to memory through address bus. Okay, then from memory to through data bus, from memory to memory buffer register, then memory buffer register to instruction register, also through data bus. Okay, here is the phase cycle. These all are time cycles in time cycle. Okay, let's make it clear. In time t1, program counters address loaded to memory address register, then memory address register through address bus we are going to memory, then from memory through data bus we are storing our data in memory buffer register. At the same time our PC is PC plus plus, means incrementing the PC value means uploading the next instructions address in the PC. In the time 2 where both from memory the instruction loaded to the memory buffer register and the program counter value is incremented in one clock cycle, T2 clock cycle. Okay, in T3 clock cycle the memory buffer register data, it may be instruction or data in memory buffer register, the instruction in memory buffer register loaded to the instruction register. This is our phase cycle. Let's move to instruction decode or also called decode instruction cycle. In instruction decode, the instruction in instruction register will be decoded by control unit. Control unit play a vital role. Control unit decode the instruction inside the instruction register. Okay, if the instruction is in immediate addressing, I have discussed about addressing modes. If the instruction is in immediate addressing, then we have both operand value and opcode, all details about the operation, all information about the operation. If it is a direct or indirect, then there will be again a process, operand fetch will be done. The process like the cycle like instruction fetch, there is again a cycle run which is operand fetch. Only which case? All cases except the immediate addressing mode. Operand fetch will be done in all cases except immediate addressing mode. इमीडिएट एड्रेसिंग मोड में क्या होगा ना, हमारा जो ऑपकोड है, ऑपरेंड वैल्यू है, सब कुछ क्या होगा इंस्ट्रक्शन में ही दिया गया होगा, तो उसमें क्या होगा ना, ऑपरेंड फेच करने की कोई ज़रूरत नहीं है. ओके, देन क्या होगा, देखो क्या होगा, हमारे पास हमारा इंस्ट्रक्शन था किसमें ना, इंस्ट्रक्शन रजिस्टर में. इंस्ट्रक्शन रजिस्टर से इसको कौन डिकोड किया ना, कंट्रोल यूनिट डिकोड किया. कंट्रोल यूनिट इसको डिकोड किया. देख कंट्रोल यूनिट डिकोड करने के बाद कंट्रोल यूनिट डिकोड करेगा, फिर क्या चेक करेगा, कंट्रोल यूनिट डिकोड्स द इंस्ट्रक्शन inside the instruction register and check the operation or the opcode. Okay, then the values or the operand values from instruction register goes to memory buffer register, then goes to memory data register, and then goes to ALU for execution. This is execution stage. From ALU, this is execution stage. Okay, this is in immediate addressing. This is in immediate addressing. Okay, let's discuss about direct addressing mode. In direct addressing mode, the instruction format is like this: mode bit, then opcode, then operand address. Okay, operand address, it is direct addressing. In direct addressing, our control unit will decode this instruction. Then here is the operand address is given. Okay, then the operand address is go from instruction register to memory address register. Okay, the operand address will be go from instruction register to memory address register. Then memory address register, so from memory address register through our address bus, from memory we find our data in memory, then from memory to memory buffer register through data bus. Make it clear: instruction register, address bus through memory address register, then same address bus through memory, then from memory through data bus we have memory data register or memory buffer register, then again goes for ALU for execution. This is direct addressing. Okay, then let's discuss about indirect addressing. From indirect addressing, the instruction the address is given in indirect addressing mode. Okay, a address is given. In that address we get the address of our operand. Okay, in means first address, inside this address we will get address of operand. Okay, it is clear? From instruction, the address goes to memory address register, then from memory address register to memory, then memory to memory buffer register, and here in memory buffer register we get this address of operand. Okay, again from memory buffer registers we get to instruction register. Okay, we get to instruction register. Let's make it clear. And again from instruction register we again go to memory address register, and from memory address register to memory, then memory to memory buffer register, then memory buffer register to memory data register. Okay, make it clean fast. then memory data register to ALU. From this we have our instruction decode phase. We have our instruction decode phase. Okay, let's make it clear. I have discussed about all three addressing modes. In all three addressing modes, how it actually running instruction decode, how it is doing or how it is decoding the instruction. Okay, then the third stage is execution. The third stage is execution, also called instruction execution stage. Okay, then the data in our memory buffer register or memory data register plus another data added in ALU. In instruction decoding phase, we have discussed about MDR. The final data is stored in MDR, then from MDR to ALU. Okay, the data takes place for the data goes to the ALU for execution, and from after this the execution stage, instruction execution stage occurs. Simple, that the data will be gone for execution to the ALU. This is called instruction execution stage. After the execution, there are also a stage called write back stage. In write back stage, the outcome or result will be stored in our destination address. It may be memory or it may be register itself. Okay, these are the instruction life cycle or instruction cycle. Thank you. And if you are continuing the video till now, then make a like. Thank you.